The history of database architecture is a story of shifting boundaries. For decades, the standard model was clear. You had your application running on one server and your data living in a separate database server. They talked to each other over a network, sending requests back and forth. This separation offered safety and isolation, but it introduced latency and complexity. Every query required a trip across the wire, a handshake, and a response. Now consider the specific challenge of graph data. Graph databases are designed to handle relationships. Think of a social network or a fraud detection system where the connections between items are just as important as the items themselves. Traditionally, you would spin up a dedicated graph database service like Neo4j. This is a heavy process. It requires its own infrastructure, its own maintenance, and its own network overhead. Some developers try to cheat by using standard relational databases and storing graph structures in JSON-B fields. This is a workaround. It works for small datasets, but it lacks the specialized indexing and traversal algorithms that a true graph engine provides. Enter Graphio. This is a Rust-based graph database engine that proposes a different path. Instead of running as a separate server process, Graphio is designed to be embedded directly into your application binary. It lives inside your application runtime. This means there is no network hop for internal queries. The database becomes part of the code itself. The promise here is significant. By removing the network layer and the process boundary, you eliminate a massive source of latency. The architecture relies heavily on the Rust programming language. Rust is known for its memory safety and concurrency features. In the context of a database, this means the engine can manage memory without the garbage collection pauses that slow down systems like Java or Python. It can also handle multiple threads safely without data races. This allows the database to utilize all available cores on the central processing unit without the risk of corrupting the data. The result is a lean system that can handle high-frequency query patterns with minimal resource overhead. This brings us to the claim of speed. Proponents suggest performance gains of up to 1,000 times in specific benchmarks compared to traditional solutions. This is not just about raw speed. It is about the ability to run complex graph traversals in microseconds rather than milliseconds. For applications where every millisecond counts, such as real-time recommendation engines or high-frequency trading systems, this shift from external service to embedded library is transformative. It implies a move towards serverless or decentralized data architectures, where the database lives directly within the application runtime rather than as a separate service. However, we must address the elephant in the room. The development history of this project has sparked significant debate in the community. On technical forums, there is skepticism surrounding the pace of progress. Observers have noted an unusually high volume of commits and code generation in single weeks. This pattern suggests a heavy reliance on artificial intelligence tools to generate code rather than traditional human engineering. Critics argue this approach may result in a fragile system lacking the rigorous design typical of established graph databases. This is not a dismissal of the technology, but a necessary caution. When code is generated at scale, the risk of subtle bugs increases. Without human review of every line, the system might behave unpredictably under edge cases. There is currently a notable lack of independent validation regarding its performance benchmarks or confirmed production usage. While proponents highlight Graphio's potential to rival modern engines like Kuzu or DuckDB, the community remains divided. Some view it as a portfolio piece rather than a mature product. So where does this leave us? The embeddable nature of Graphio implies a shift in how we think about data storage. It challenges the assumption that every database needs a separate process. For edge devices or microservices where traditional graph databases are too heavy, this model offers a compelling alternative. If the codebase is stable, it could disrupt the embedded graph database market. But until independent audits or widespread adoption occur, Graphio remains a promising but unproven experiment. The decision to use it depends on your risk tolerance. If you are building a prototype or a research project where speed of development matters more than long-term stability, the embedded model is attractive. It allows you to test graph queries without setting up a complex infrastructure. However, if you are building a critical production system that must run reliably for years, the lack of maturity is a significant factor. You are betting on a system that has not yet been stress-tested by the broader community. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.